Consider the following problem. Find two numbers whose sum is 23 and whose product is a maximum. When you're done considering it, use calculus to solve the problem. Let's let x and y be our two numbers, if that's alright with you. I know that's very unoriginal, but we'll just stick with the status quo. X and y for our variables. Now what do we know? The two numbers add up to 23. So x plus y is equal to 23. We want to maximize the product. So we want to maximize, we'll call it P. That stands for product, another very original variable name. And that's going to be x times y. Well, the problem here is that P is a function of two variables. Well, since x plus y is equal to 23, we can say that y is equal to 23 minus x. And so since y is equal to 23 minus x, we can write P as a function of x by substituting in 23 minus x for y. So we have x times a quantity of 23 minus x. Now, if I distribute that x through there, that gives me 23x minus x squared, and that, my friends, is a function. It's a quadratic function, a negative leading coefficient. The graph of that is a parabola opening down. It's going to have a maximum value. We want to maximize this function. How do we do that? Well, we take the derivative and set it equal to 0. The derivative is 23 minus 2x. And if we set 23 minus 2x equal to 0, that means 23 is equal to 2x, and x then is equal to 23 halves. Now, I know that x equals 23 is going to be a max, since, well, a quick way to tell is that p double prime of x is equal to negative 2. That's less than 0. Remember that if our second derivative is negative, that means we're concave down. That means that the critical number has to be sitting at the top as a max. Okay, so that means that if x is 23 halves, not 23, 23 halves, well then y is also equal to 23 halves. Y is 23 minus 23 halves, which is 23 halves. So we get a maximum product of P of 23 halves, which is 23 halves times 23 halves, which turns out to be 132.25. And it occurs, of course, when x and y are 23 over 2. So those are the two numbers, again, whose sum is 23 and whose product is maximum.